The allure of Mars has captivated humanity for centuries, drawing the curious and the adventurous alike. Its rusty red surface, visible even to the naked eye, has whispered tales of ancient civilizations and the possibility of extraterrestrial life. These whispers have fueled our imaginations and inspired countless stories and theories. Now in the 21st century, the dream of reaching Mars has transformed into a tangible reality. With each passing year, our technology advances, bringing us closer to making this dream a reality. We stand on the precipice of sending humans to the Red Planet, not just for fleeting visits, but for long-term habitation. This vision includes building sustainable colonies where humans can live, work, and thrive. This ambition, however, is not without its challenges. The journey to Mars and the subsequent survival on its surface present a host of formidable obstacles. Surviving on Mars for a decade, let alone establishing a permanent presence, demands overcoming a myriad of obstacles. These include dealing with the planet's harsh environment, limited resources, and the psychological effects of isolation. The Martian environment is unforgiving, a stark contrast to the hospitable cradle of Earth. Its barren landscape and extreme conditions pose significant challenges to human survival. The atmosphere, thin and carbon dioxide rich, cannot sustain human life. This necessitates the development of advanced life support systems to provide breathable air. Water, the elixir of life, exists primarily as ice locked beneath the surface. Extracting and utilizing this water is crucial for sustaining human life on Mars. Temperatures fluctuate wildly, plunging to bone-chilling lows during the Martian night. These extreme temperatures require innovative solutions to keep habitats warm and safe, and the ever-present threat of radiation exposure looms large. Protecting astronauts from harmful cosmic rays is a critical concern for long-term missions. Yet these challenges, while daunting, are not insurmountable. Human ingenuity and determination have always found ways to overcome adversity. Human ingenuity, driven by the indomitable spirit of exploration, has always found ways to overcome adversity. Our past achievements in space exploration serve as a testament to our capabilities. The key to surviving on Mars lies in our ability to adapt. We must be prepared to innovate and find new ways to live in this alien environment. We must transform from passive inhabitants of Earth to ingenious architects of our own Martian ecosystems. This transformation requires creativity, resilience, and a willingness to embrace new challenges. This endeavor requires a multifaceted approach, encompassing technological innovation, meticulous planning, and an unyielding commitment to collaboration. International cooperation will be key to our success. We must develop self-sustaining habitats that provide breathable air, ensuring that our life support systems are reliable and efficient. Cultivate food in Martian soil, using advanced agricultural techniques to grow crops in an environment that is far from Earth-like, and extract water from the planet's icy depths. This water will be essential for drinking, growing food, and other daily needs. The journey ahead will be arduous, fraught with unforeseen challenges and setbacks. But with determination and perseverance, we can overcome these obstacles. But the rewards are immeasurable. Establishing a human presence on Mars will be a monumental achievement for our species. Establishing a human presence on Mars is not merely about escaping the confines of Earth. It's about expanding our horizons and exploring new frontiers. It's about pushing the boundaries of human ingenuity, unlocking the secrets of the Red Planet's past, and ensuring the survival of our species beyond Earth's embrace. This endeavor will open up new possibilities for future generations. The following sections will delve into the practical strategies and technological marvels that will enable us to not only survive, but thrive on Mars. Join us as we explore the future of human life on the Red Planet. The Martian atmosphere presents a significant hurdle to human survival. Composed primarily of carbon dioxide with a mere trace of oxygen, breathing on Mars without assistance is impossible. The air is so thin that it would be like trying to breathe at an altitude 3 times higher than Mount Everest. The thin atmosphere also offers scant protection from harmful solar and cosmic radiation. This radiation can cause severe health issues, including increased cancer risks and damage to the central nervous system. To survive, we must create our own breathable oases within the Martian landscape. These habitats will need to be meticulously designed to provide a safe and sustainable environment for humans. The primary challenge lies in generating a continuous supply of oxygen. Without it, our efforts to colonize Mars would be futile. Traditional oxygen tanks, while useful for short-term missions, are impractical for long-term habitation due to the logistical nightmare of constantly transporting them from Earth. The cost and complexity of such operations are simply too high. Instead, we must turn to on-site oxygen generation. This approach not only reduces dependency on Earth but also ensures a more sustainable and efficient way to support human life on Mars. One promising solution is the MOXIE, or Mars Oxygen In Situ Resource Utilization Experiment, instrument currently operational on the Perseverance rover. This groundbreaking technology is paving the way for future human exploration. MOXIE successfully converts Martian carbon dioxide into breathable oxygen through a process called solid oxide electrolysis. This process splits carbon dioxide molecules to produce oxygen and carbon monoxide. Scaling up MOXIE's technology will be crucial for future human missions. Larger versions of this technology could potentially support entire colonies. Larger, more efficient oxygen generation plants will need to be deployed, capable of producing and storing sufficient oxygen to sustain entire Martian colonies. These plants will be the backbone of our life support systems. These plants will form the heart of our life support systems, continuously replenishing our breathable atmosphere. They will ensure that we have a steady supply of oxygen, crucial for our survival. However, oxygen is only one part of the equation. We must also manage the levels of carbon dioxide to maintain a safe environment. We must also address the issue of carbon dioxide removal. Excess carbon dioxide can be harmful, leading to respiratory issues and other health problems. While plants can naturally convert carbon dioxide into oxygen, relying solely on photosynthesis for carbon dioxide scrubbing in an enclosed Martian habitat is risky. The process is slow and may not be sufficient to meet the needs of a growing colony. Mechanical systems will be essential to ensure a safe and balanced atmosphere. These systems can efficiently remove excess carbon dioxide, maintaining the delicate balance required for human life. These systems will capture excess carbon dioxide and either store it for potential use in other applications or vent it safely outside the habitat. This dual approach ensures that we can manage our resources effectively. The creation of breathable environments within our Martian habitats is paramount. Without a stable and breathable atmosphere, our efforts to colonize Mars would be in vain. Without a constant supply of oxygen and effective carbon dioxide removal, survival on the red planet is impossible. These systems are the lifeline that will enable us to thrive in this new frontier. The red planet, with its barren, rusty red soil, may seem an impossible place to grow food. However, beneath the surface lies the potential for Martian agriculture. Using innovative techniques like hydroponics and aeroponics, we can transform Martian regolith into fertile ground, cultivating a sustainable food supply for future Martian colonists. Hydroponics, a method of growing plants without soil, offers a promising solution for Martian agriculture. In this system, plants are grown in nutrient-rich water solutions, their roots suspended in a carefully controlled environment. This eliminates the need for traditional soil, instead using Martian regolith as a substrate to support the plants. Aeroponics takes this concept a step further, suspending plant roots in the air and misting them with nutrient-rich solutions. This method maximizes water and nutrient efficiency, crucial factors in the Martian environment. The selection of crops will be critical for Martian agriculture. Hardy, fast-growing plants with high nutritional value such as lettuce, spinach, and strawberries will be early contenders. As our understanding of Martian agriculture grows, we can expand our repertoire to include more complex crops, potentially even adapting Earth crops to thrive in Martian conditions. The greenhouses themselves will need to be designed to optimize plant growth while minimizing resource consumption. Transparent, inflatable structures made from durable materials will allow sunlight to penetrate, while LED lighting systems can supplement natural light during the Martian night or during dust storms that block sunlight. Sensors will constantly monitor temperature, humidity, and nutrient levels, ensuring optimal growing conditions. The ability to cultivate food on Mars is not just about sustenance, it's about establishing a closed-loop system that minimizes dependence on Earth. Water, the lifeblood of our planet, is equally crucial for survival on Mars. Without it, sustaining human life on the red planet would be impossible. While the red planet appears arid and desolate, water does exist, locked away as ice beneath the surface and in the polar ice caps. These hidden reservoirs hold the key to future human colonization. Accessing and utilizing this precious resource is paramount for any long-term human presence. Without a reliable water source, establishing a sustainable colony would be a daunting challenge. Remote sensing from orbit has identified vast deposits of water ice beneath the Martian surface. These discoveries have fueled hopes and plans for future missions aimed at tapping into these reserves. These subsurface reservoirs, often located at depths accessible with current drilling technology, represent a valuable source of water for future Martian colonies. The challenge lies in reaching and extracting this water efficiently. Extracting this water will require deploying specialized drilling rigs capable of penetrating the Martian regolith. These rigs must be robust enough to withstand the harsh Martian environment. Once extracted, the ice can be melted and purified for human consumption and other uses. This process will be vital for providing drinking water, growing food, and supporting industrial activities. The Martian polar ice caps, composed primarily of water ice and frozen carbon dioxide, represent another potential water source. These ice caps could be mined to support human activities on Mars. However, their remote location and extreme environmental conditions pose significant logistical challenges for extraction and transportation. Overcoming these obstacles will require innovative solutions and advanced technology. Technological advancements in robotic exploration and resource extraction will be crucial for tapping into these frozen reservoirs. Robots can operate in conditions too harsh for humans, making them ideal for this task. Another promising technology for water extraction is the atmospheric water generator, or AWG. These devices can extract water directly from the Martian atmosphere. AWGs extract moisture from the Martian air, even from the thin atmosphere, and condense it into usable water. This technology could provide a supplementary water source, especially in areas where ice is scarce. While the current generation of AWGs has limited output, advancements in material science and energy efficiency could make them a viable option for supplementing water supplies on Mars. Future iterations of AWGs could significantly boost water production. Once extracted, water will need to be carefully managed and conserved. Efficient water management systems will be essential to ensure a steady supply for all needs. Closed-loop water recycling systems will be essential, purifying and reusing wastewater for various purposes, including hygiene, agriculture, and industrial processes. These systems will maximize the utility of every drop of water. Water on Mars is a precious commodity. Every effort must be made to use it wisely and efficiently. Finding, extracting, and conserving it will be a constant endeavor, requiring ingenuity, technological innovation, and a deep respect for this life-giving resource. The success of human missions on Mars hinges on our ability to manage this vital resource. The landing is rough. Red dust fills the air as the spacecraft settles onto the barren landscape. Stepping out onto Mars, the first settlers feel a mix of awe and trepidation. The air is thin, the gravity strange. Above, a pale sun hangs in the alien sky. There's no sound but the wind whistling past their helmets. This is Mars, a planet of stark beauty and unforgiving challenges. This is their new home. The first tentative steps on the red dust mark the beginning of an extraordinary adventure. They are pioneers, explorers, the first humans to set foot on Mars. The first priority is survival. The habitat modules prefabricated on Earth are quickly assembled. They provide a fragile bubble of life support against the harsh Martian environment. Inside, every breath of air, every drop of water is precious, carefully recycled, and reused. The settlers are acutely aware of their vulnerability, their lives depending on the smooth functioning of these machines. Scientists conduct experiments, engineers tinker with equipment, doctors monitor the health of the crew. In their downtime, settlers read, play games, even grow vegetables in hydroponic gardens. The taste of fresh food, a luxury on Earth, is a source of immense satisfaction. Dust storms, some lasting for weeks, plunge the habitat into darkness. Every day brings new problems to solve, new dangers to overcome. The settlers learn to adapt, to improvise, to rely on each other for support. Slowly, the settlers begin to feel a sense of belonging, of connection to this alien world. As the initial shock of arrival fades, the settlers begin the complex task of building a new society. They are a diverse group, drawn from all corners of Earth, each with their own skills, beliefs, and dreams. Yet, they are united by a common purpose: to create a new home for humanity on Mars. Engineers maintain the life support systems and work on expanding the habitat. Scientists conduct research, exploring the planet's geology, atmosphere, and potential for life. doctors tend to the physical and mental health of the community. Each individual plays a vital role in the survival and success of the colony. The challenges of living on Mars foster a strong sense of community. The settlers come from diverse cultural backgrounds, bringing with them a rich tapestry of languages, traditions, and beliefs. On Mars, these differences are not barriers but building blocks, contributing to the richness and resilience of the emerging Martian culture. While English is the designated language of the colony, a Martian dialect quickly emerges, incorporating words and phrases from the settlers' various native tongues. This new language, a blend of Earth and Mars, becomes a symbol of their shared identity as Martians. Holidays from Earth are celebrated with a Martian twist, incorporating elements of the new environment and their shared experience. New traditions emerge, unique to Mars, celebrating milestones in the colony's development or commemorating significant events. The result is a vibrant and dynamic culture, a fusion of Earth's heritage and the unique experiences of life on Mars. Leadership on Mars is a delicate balancing act. The survival of the colony depends on the settlers' ability to work together effectively, to make difficult decisions under pressure, and to maintain morale in the face of constant challenges. In the early days, leadership emerges organically, based on expertise and experience. The most skilled engineers, doctors, and scientists find themselves thrust into positions of responsibility. Their decisions have life or death consequences, their actions shaping the fate of the entire colony. As the colony grows, more formal structures of governance are established. Councils are elected, representing the diverse perspectives and interests of the community. The best leaders are those who lead by example, sharing both the burdens and the triumphs of life on Mars. Life in a confined and isolated environment, even one as extraordinary as a Martian colony, inevitably leads to conflict. The pressures of survival, the close proximity of living and working spaces, and the stresses of adapting to an alien world can test even the strongest relationships. Disputes arise over resource allocation, work assignments, even personal preferences. Resolving conflicts peacefully and fairly is crucial for the survival of the colony. Mediation and dialogue are encouraged, with designated individuals trained in conflict resolution techniques. By embracing open communication, active listening, and a willingness to compromise, the settlers learn to navigate disagreements constructively, emerging from conflict stronger and more united. The traditional concept of money holds little meaning on Mars. With resources scarce and the focus on collective survival, a new economic system emerges, based on barter, shared resources, and the principle of from each according to their ability to each according to their need. In the early days, the colony operates on a system of shared resources. Food, water, air, and other essentials are distributed equally, regardless of one's role or contribution. As the colony grows and diversifies, a system of barter emerges. Individuals trade goods and services based on their skills and needs. This barter system fosters a sense of community and interdependence. The Martian economy is a work in progress, constantly evolving to meet the changing needs of the colony. Life on Mars is not all work and no play. The settlers recognize the importance of community, celebration, and the human need for connection, laughter, and joy. They create new traditions, celebrate old ones with a Martian twist, and find moments of joy and wonder amidst the challenges of life on a frontier world. One of the most anticipated events is the annual Landing Day celebration, commemorating the arrival of the first settlers on Mars. Holidays from Earth are adapted to their new reality. Thanksgiving becomes a celebration of the Martian harvest, with hydroponically grown vegetables taking center stage. New traditions emerge, unique to Mars. These celebrations are essential for the mental and emotional well-being of the colonists. Education is a top priority on Mars, not just for the children born on the planet, but for all settlers. Lifelong learning is essential for adapting to the challenges of a new world, fostering innovation, and ensuring the transmission of knowledge to future generations. The first schoolhouse on Mars is a testament to the settlers' ingenuity and resourcefulness. Housed in a repurposed habitat module, it's a place where children learn alongside adults, where traditional subjects like math and science are taught alongside Martian-specific skills like hydroponic farming and habitat maintenance. The curriculum is designed to be hands-on and experiential. The settlers recognize that education is not just about acquiring knowledge. It's about cultivating critical thinking, problem solving, and a thirst for exploration. As the years on Mars turn into decades, the settlers begin to contemplate their legacy. They are not just pioneers but also founders, laying the foundation for a new society that will one day stretch far beyond the confines of their initial habitat. The first generation born on Mars will have a unique perspective. They will grow up under a crimson sky, their playground the dusty plains and canyons of an alien world. The settlers are determined to create a society that is not just sustainable but also just and equitable. They have learned from the mistakes of Earth, vowing to build a society free from the divisions and conflicts that have plagued humanity for millennia. They dream of a future where Mars is not just a colony, but a thriving planet, a testament to the resilience and ingenuity of the human spirit. The legacy of the first Martian settlers will be measured not just in the structures they build, but also in the values they instill in future generations. Life on Mars takes a toll on the human psyche. The isolation, the confinement, the constant threat of danger, these are challenges unlike any faced on Earth. Maintaining mental health is as crucial as maintaining physical health, and the settlers develop innovative ways to support each other's emotional well-being. Virtual reality technology provides a much-needed escape, allowing settlers to immerse themselves in simulated environments of Earth. Support groups and counseling sessions provide a safe space for settlers to share their anxieties, fears, and hopes. The settlers recognize the importance of human connection in maintaining mental health. They organize social gatherings, movie nights, even virtual dance parties, anything to foster a sense of community and belonging. The challenges of living on Mars push the boundaries of human resilience, revealing the strength of the human spirit. Technology is both the enabler and the potential pitfall of life on Mars. It's what makes human survival possible, but it also threatens to isolate individuals, replacing human interaction with virtual experiences. Finding the balance between technological reliance and genuine human connection is an ongoing challenge for the Martian community. Advanced communication systems allow settlers to stay in touch with loved ones on Earth. But the settlers recognize the importance of face-to-face interaction, of shared meals, laughter, and the simple act of being present with one another. They make a conscious effort to limit their reliance on technology to prioritize human connection. They strive to harness the power of technology to improve their lives while remaining mindful of the importance of human connection. After 10,000 days on Mars, the Red Planet is no longer an alien world but a familiar home. The settlers have endured hardships, overcome challenges, and built a society that is both a testament to human ingenuity and a beacon of hope for the future. The habitat has expanded into a sprawling complex, a testament to their perseverance and innovation. Greenhouses flourish, providing fresh food and a welcome splash of color. Children born under a Martian sky dream of exploring the farthest reaches of their adopted planet. The settlers have learned to live in harmony with their environment, harnessing its resources while minimizing their impact. They have embraced the challenges and opportunities of life on a new world, forging a unique identity as Martians. They are no longer just survivors but builders, dreamers, and pioneers. Mars is now their home. Imagine standing on the rusty red surface of Mars. The sun, a distant ember, casts long, eerie shadows across the desolate landscape. Dust devils dance in the thin, cold air. Overhead, a pale pink sky stretches towards the horizon. This is Mars, our planetary neighbor, a world of stark beauty and tantalizing mystery. For centuries, we have gazed at Mars with wonder and speculation. Today, that dream of reaching out to the red planet is closer than ever. Rovers traverse its surface, sending back breathtaking images and invaluable data. They are our eyes and ears on Mars, paving the way for future human exploration. The journey to understanding Mars is a testament to human curiosity and ingenuity. It's a journey driven by a fundamental desire to explore the unknown, to push the boundaries of our knowledge, and to seek answers to some of the most profound questions we can ask. Are we alone in the universe? Could life exist, or have existed, beyond Earth? The answers to these questions lie buried in the Martian soil, hidden in its ancient rocks, and whispered on the thin Martian winds, and we are closer than ever to uncovering them. Our quest to explore Mars began in earnest in the 1960s. Early missions like NASA's Mariner program provided our first glimpses of the Martian surface. These flybys revealed a world scarred by impact craters, ancient volcanoes, and vast canyons. They hinted at a planet with a dynamic past, a past that may have once held the potential for life. Then came Viking 1, the first spacecraft to successfully land on Mars in 1976. Viking and its twin, Viking 2, marked a pivotal moment in our exploration of the Red Planet. They sent back the first color images from the Martian surface and conducted the first experiments searching for signs of life. Over the decades, our understanding of Mars has grown with each successive mission. Orbiters like Mars Global Surveyor and Mars Reconnaissance Orbiter have mapped the planet in unprecedented detail, revealing evidence of past water, a key ingredient for life as we know it. The search for water is central to our exploration of Mars. Where there was water, there might have been life. And the evidence suggests that Mars was once a very different place. Billions of years ago, liquid water likely flowed on the Martian surface, carving out the riverbeds and deltas we see today. The discovery of evidence for past liquid water on Mars was a game-changer. It fueled our imaginations and intensified our search for signs of ancient life. Rovers like Spirit and Opportunity found evidence of past environments that could have been habitable. Curiosity, with its sophisticated suite of instruments, confirmed the presence of ancient lakes and streams. The evidence continues to mount. Perseverance, the most advanced rover ever sent to Mars, is exploring an ancient lakebed, collecting rock and soil samples that could hold the key to unlocking the secrets of Mars's past. These samples, when returned to Earth, will be analyzed in labs around the world, providing us with our best chance yet of finding evidence of ancient Martian life. Mars isn't alone in its journey around the Sun. It has two small moons, Phobos and Deimos, which are thought to be captured asteroids. These enigmatic objects hold clues to the formation of the Martian system, and could one day serve as stepping stones for human exploration further into the solar system. But the Martian surface itself is full of mysteries. Recurring slope lineae, dark streaks that appear on Martian slopes during the warmer months, suggest the presence of briny water flowing just beneath the surface. These features could be potential habitats for microbial life and are a prime target for future exploration. The Martian landscape is also sculpted by giant dust storms that can engulf the entire planet. These storms, while challenging for our robotic explorers, are a testament to the dynamic nature of Mars. Understanding these storms is crucial for planning future human missions and for unraveling the complex climate system of the Red Planet. Section 5. The question of life and the dream of terraforming. The possibility of life on Mars, even in microbial form, is a profound one. It would forever change our understanding of our place in the universe. If we find that life arose independently on both Earth and Mars, it would suggest that life is not a fluke, but rather a common occurrence in the cosmos. The discovery of life on Mars would also have profound ethical implications. How would we interact with this life? What responsibilities would we have to protect it? These are questions that we must grapple with now before we potentially face them in the future. Some scientists and visionaries even dream of terraforming Mars, transforming it into a habitable world for humans. While this remains a distant prospect, it sparks our imagination and challenges us to consider the possibilities of engineering on a planetary scale. Section 6. A global endeavor. The quest for resources and knowledge. The exploration of Mars is no longer the sole domain of national space agencies. Private companies are emerging as key players, developing innovative technologies and driving down the cost of space travel. This new era of space exploration promises to accelerate our progress and open up new opportunities for collaboration and discovery. The quest for resources is also driving Mars exploration. The planet is thought to hold valuable minerals and other resources that could be utilized in the future. However, the extraction and utilization of Martian resources raise ethical and environmental considerations that must be carefully addressed. Exploring Mars is not just about seeking answers to scientific questions, it's about pushing the boundaries of human ingenuity and expanding our presence in the solar system. It's about inspiring future generations and ensuring the long-term survival of our species. Section 7. Visionaries and Trailblazers, Shaping the Martian Dream. Throughout history, visionaries and pioneers have dreamt of reaching Mars. From Percival Lowell's early observations of Martian canals to Wernher von Braun's ambitious plans for human missions, these individuals have shaped our understanding of Mars and inspired generations of scientists, engineers, and explorers. Today, individuals like Elon Musk and Jeff Bezos are carrying the torch, pushing the boundaries of technology and private enterprise to make human missions to Mars a reality. Their bold visions and unwavering determination are essential for overcoming the immense challenges of interplanetary travel. But it's not just about getting to Mars, it's about what we do when we get there. Artificial intelligence, or AI, is playing an increasingly important role in Mars exploration. AI-powered rovers are capable of making decisions autonomously, navigating complex terrain, and conducting scientific experiments without direct human intervention. As AI technology continues to advance, it will become an even more indispensable tool for exploring Mars and other celestial bodies. However, the use of AI in space exploration also raises ethical questions. How much autonomy should we give to AI systems? What are the implications of AI making decisions that could impact the outcome of a mission, or even the discovery of life? These are questions that we must carefully consider as we continue to integrate AI into our space exploration endeavors. The exploration of Mars is a testament to human ingenuity and our insatiable thirst for knowledge, but it is also a journey that demands responsibility, ethical considerations, and a commitment to preserving the integrity of this alien world. The future of Mars exploration is likely to be shaped by both international cooperation and competition. Collaborative missions like the ExoMars program between the European Space Agency and Roscosmos demonstrate the power of pooling resources and expertise to achieve common goals. However, the emergence of new spacefaring nations and private companies also raises the specter of competition. This competition, while potentially driving innovation, also carries the risk of duplication of effort and a lack of coordination. Ultimately, the most successful approach to Mars exploration will likely involve a balance of cooperation and competition. By working together, while also pushing the boundaries of innovation, we can maximize our chances of unlocking the secrets of the Red Planet and ensuring a bright future for humanity among the stars. Each mission to Mars adds a new thread to the tapestry of our understanding. We've gone from blurry images of a distant red dot to high-resolution panoramas of ancient lake beds and towering mountains. We've analyzed the Martian atmosphere, probed its soil, and even listened for the faint whispers of seismic activity. But the more we learn, the more we realize how much we still don't know. Mars continues to surprise us, challenging our assumptions and pushing the boundaries of our scientific understanding. The search for life, past or present, remains a tantalizing mystery, and the prospect of one day sending humans to Mars continues to capture our imaginations. The exploration of Mars is not just about understanding another planet, it's about understanding ourselves. It's about pushing the limits of human ingenuity, confronting the vastness of the universe, and searching for answers to some of the most fundamental questions we can ask. The journey to Mars is a journey of discovery, a testament to the power of human curiosity and our unyielding desire to explore the unknown. It's a journey that is far from over. As we continue to send robotic emissaries and, one day, human explorers to Mars, we will undoubtedly make new discoveries that will rewrite our textbooks and reshape our understanding of the cosmos. The Red Planet beckons. It's a world of stark beauty, tantalizing mystery, and perhaps even the faint echoes of life. And as we stand on the precipice of a new era of space exploration, one thing is certain: the quest to unravel the secrets of Mars has only just begun. Images. The allure of Mars lies not just in its proximity to Earth but also in its These rovers were designed to search for signs of past water activity, and they did not disappoint. Discovery brings us one step closer to understanding whether life is a unique phenomenon on Earth or a common. And finding it on Mars could mean that the planet once harbored life, or could potentially support life in the future. Back from orbit revealed ancient riverbeds carved by flowing water over eons. More hospitable place. This ancient water could have provided the necessary conditions for life beyond our home planet. Following in the footsteps of their predecessors, the Curiosity and Perseverance rovers represent a new generation of Martian explorers, equipped with cutting-edge technology to delve even deeper into the Red Planet's secrets. These rovers are not just machines, they are the embodiment of human ambition and scientific curiosity, designed to push the boundaries of what we know about Mars and, by extension, our own place in the universe. Curiosity, landing in 2012, set its sights on Gale Crater, a vast impact basin chosen for its potential to harbor signs of past habitability. This location was meticulously selected by scientists who believed that the crater's ancient lakebed could hold clues to Mars's wetter past. Over the years, Curiosity has traversed this rugged terrain, climbing Mount Sharp and uncovering evidence of ancient water flows and complex organic molecules. Its mission, to determine if Mars could have ever supported microbial life. By analyzing rock samples and soil, Curiosity has provided invaluable data that suggests Mars was once a more hospitable environment, potentially capable of supporting life as we know it. The rover's findings have laid the groundwork for future missions, offering a tantalizing glimpse into the planet's ancient past. Perseverance, touching down in 2021, targeted Jezero Crater, a site believed to have once been a lake fed by a flowing river. This ancient lakebed is thought to be one of the most promising locations to search for signs of ancient life. The rover's landing was a feat of engineering, showcasing the incredible precision and skill required to navigate the Martian surface. Its primary objective is to seek signs of ancient life, collecting rock and soil samples that could one day be returned to Earth for analysis. These samples are carefully stored in sealed tubes, preserving them for future missions that aim to bring them back to our planet. The analysis of these samples could provide definitive evidence of past life on Mars, answering one of humanity's most profound questions. Perseverance also carries Ingenuity, a small helicopter designed to test the feasibility of powered flight in the thin Martian atmosphere. This groundbreaking experiment has already achieved several successful flights, demonstrating that aerial exploration of Mars is possible. Ingenuity's flights are not just a technological marvel, they open up new possibilities for future missions, allowing us to explore areas that rovers cannot reach. These rovers are more than just sophisticated robots. They are extensions of our human curiosity, our insatiable desire to explore the unknown. They represent the culmination of decades of research, engineering, and international collaboration, embodying the spirit of exploration that drives us to seek out new frontiers. They traverse the Martian landscape, analyzing rocks, drilling into the surface, and collecting data that is beamed back to Earth, providing us with an unprecedented glimpse into this alien world. The information they send back helps scientists to understand the planet's geology, climate, and potential for life, offering insights that could one day inform human missions to Mars. Their instruments are a testament to human ingenuity, capable of analyzing the composition of rocks, detecting trace amounts of organic molecules, and even studying the Martian weather. These sophisticated tools allow the rovers to conduct experiments and gather data that would be impossible to obtain from Earth, pushing the boundaries of our scientific knowledge. The data they collect is helping us to piece together the puzzle of Mars's past, revealing a planet that was once warmer, wetter, and potentially habitable. Each discovery brings us one step closer to understanding the history of Mars and its potential to support life, both in the past and possibly in the future. The legacy of curiosity and perseverance will undoubtedly inspire future generations of explorers, scientists, and dreamers as we continue our quest to uncover the mysteries of the cosmos. The exploration of Mars is not without its challenges. The red planet presents a harsh and unforgiving environment, with extreme temperatures, a thin atmosphere, and intense radiation. Designing and operating rovers capable of withstanding these conditions is a testament to human ingenuity and the relentless pursuit of knowledge. Every aspect of these robotic explorers, from their heat shields to their wheels, has been meticulously engineered to withstand the rigors of the Martian environment. They are equipped with redundant systems, ensuring that if one component fails, another can take its place. Their software is constantly updated from Earth, allowing them to adapt to unforeseen challenges and continue their missions. One of the most remarkable feats of engineering is the rover's ability to navigate the Martian terrain autonomously. Using a combination of cameras, sensors, and sophisticated software, they can plan their routes, avoid obstacles, and even select scientifically interesting targets for investigation. This autonomy is crucial as the vast distances involved make real-time control from Earth impossible. The resilience of these rovers is a testament to the dedication and skill of the engineers and scientists who designed and built them. Despite facing dust storms, mechanical issues, and the wear and tear of exploration, they continue to operate far beyond their initial life expectancies, pushing the boundaries of what is possible in robotic